Dirty Scrap Podcast.
So again, Patrick, I really appreciate that you're making time for us. As you know, the idea of this podcast is to give people knowledge about what the industry is doing in terms of sustainability and in terms of, let me just add Danny that is coming here right now. And obviously, what we want to do is to, introduce people new ideas, new trends, and try to clarify what is going on in the industry in terms, as I said, of sustainability, in terms of how the industry is moving in so many different directions to reach this green wave that we want to reach. And first of all, I want to ask you about your background. I know you are a mechanical engineer, you have like master an engineer as well. So tell me more about your background, your life, and then we will go into all these crazy ideas that you are working with.
Sure.
Mott. So let me know about you.
Sure. So a little bit about me. You're right. I am a degreed mechanical engineer. I started my career in the nuclear power industry, and my role there was to be first an accident analyst. And so I analyzed various potential accident scenarios to prove the safe operation of a nuclear power facility. And then I moved into major components, reactors, pumps, heat exchangers, steam generators, and their corresponding design, analysis, and operation. And then eventually into project management in that organization as well. I left the nuclear industry at about 10 years of experience and then joined Mott. And Mott is a precision filtration and flow control company based in Connecticut. And in Mott's business, I started in the process systems division I still work in today, but I started as a project manager, executing the design of large scale industrial filter systems for a variety of industries, oil and gas, chemical, power, food and beverage, things like that. I eventually moved into management and led our customer innovation center for a little while. And now I'm the general manager of that process systems business as well as our clean water business. So it's a lot of fun. I get to play in all aspects of the role, from pre-sale, working with customers to understand their challenges and translate them to a product, through working with the technical teams to see those products turn to life and then monitor and operate them for the next couple decades.
Nice. Yes, I can see that Mott is involved in so many different industries like space, defense, petroleum and petrochemical industry, chemical processing, food even. But let me ask you something about the energy, because nuclear power and nuclear energy is a fascinating world. Definitely is something fascinating, but I think it's something that we are putting behind because we are a little bit scared about this technology that I think we know how to use it. But before to dig into this type of topic, how is the energy industry changing through the years according to your perspective? Because as I can see, you've been in this industry for a long time. Now you are on Mott, that is filtration, and also you have like green energy approaches and everything. We will talk about that later. But how do you see the industry like moving forward in so many different directions from the energy point of view?
It's a really interesting question. And your point on nuclear energy is a really valid one too. The technology is well developed and well understood by the folks who operate it. We can do a better job of educating the general public there as well. And there's a lot of folks who do that as a full-time job. From my perspective, what I see in energy transition is actually quite interesting. So let's take oil and gas and chemical, for example. Earlier in my career at Mott, I saw a lot of focus on legacy technology, making sure that technology was reliable, had high uptime, and was debottlenecked or as efficient as possible.
Right.
Lately, I would say in the post-COVID era, so the last 3 or 4 years, I see quite a bit of investment in new disruptive technology in both spaces. Technology that changes the way products are made. And that new technology requires a different solution set behind it as well. I find this fascinating, especially in oil and gas, because it's a market that is traditionally quite conservative when it comes to embracing something new. But I see now deployment of things like biofuels, sustainable aviation fuel, carbon capture in steam methane reforming processes to make hydrogen. All these things are great investments that will allow us to still produce those building blocks that we need as a society, whether that's transportation fuels or precursors to things like clothing and personal care. But they're doing it with more of a focus on sustainability in the environment and not necessarily just a focus on pure profit. So it's great to see that balance.
Right. Yeah, and I am totally agree with you. I think in the past we saw these big corporations like not letting these people to go and move forward in this direction because everything was about money. And I think right now it's more about, hey, let's save the planet. Let's try to make something that is making a really real change in the world. But do you think these type of energies will be able to really, let's say, make sustainable future on the industry from the point of view that we really can take care of the industry on the energy side, that the energy that we will need in order to produce and manufacture, because at the end energy intensive consumption is needed, and I am not so sure if these green energies are able to sustain that industry. Do you think it is possible, or do you think it's going to be a mix between them, and we will see, like, let's see different type of developments in the industry for the next year?
Yeah, it's a great question. I think my personal perspective is anything is possible if you give it enough effort and time, right? And so in this case, time is really the key thing. You can't flip a switch and go from being a predominantly fossil fuel based high emissions energy portfolio to one that isn't overnight. It takes time. And so to be blunt, Julio, today, no, we could never account for these sustainable technologies to pick up 100% of the demand that we have. We should use them, in my opinion, as supplemental and growing and emerging technologies for now. And as best as is possible, when our demands change, we should start, in my opinion, start with a sustainable source first if it makes sense, rather than continuing to build some of the older antiquated stuff. That being said, we have plenty of highly efficient oil refineries here in the US. They will run for a number of decades quite successfully. And we need them too, just like we need natural gas plants and any other quote unquote, kind of dirty technology, so to speak. But what I see in the industry is you can still take that traditional crude oil based technology and put a bunch of elements around it that make it less impact environment. And overall, that's, again, a great thing and something we should.
Right. And this is great that you are bringing this topic here, because when you see, for example, the aluminum industry, the recycling aluminum industry that is growing a lot, and you see all these, let's say, all these goals that the industry has for the next, I don't know, 10, 20 years, even a little bit more, it is crazy to think that you will just make the primary aluminum industry disappear. It is impossible. So I think that we will need to do is to improve that primary industry to make the industry more reliable in terms of sustainability, and then try to support more and more the recycling side. Now, saying that, for me, it's a concern, for example, if we talk about the electrical vehicles. I don't know if you are aware of this data, but for example, China is building 55, almost 60% of the EVs in the whole world. And we want the United States to be like the top of the industry right now in this case, but we are closing mining here in the US. So now that we are talking about green energies and you are saying, oh, we need a mix and we need to keep these, let's say, primary sources like petrochemical sources and everything moving ahead to support what is coming in the next years. Do you think this is a real approach, or do you think in some point we will see those companies shutting down?
I think it's a real approach if we keep our horizon to, less than 50 years. 50 years from now, who knows what can happen, right?
Right, yeah.
But in the short term, I think the mix is a real approach. I think these corporations are incredibly established, highly successful. There's a lot of smart folks looking at new ways to do things.
Definitely.
And I'm confident that they will continue to do so. Like the aluminum industry, I agree with you. Primary aluminum manufacturing will not go away in the short term. Recycling and repurposing is fantastic, but you need both sources in order to meet the overall demand. I was just actually, as thinking about this meeting today, I was doing a little research this morning, and I was looking at carbon dioxide emissions. And so, it's a leading cause of global warming, lots of reasons for us to get better at it. There's an estimate that says that we discharge as a society about 36 billion tons of CO2 a year, and that nature can really only absorb half of that. And so if you think about it, our challenge is how do we, as quickly as possible, make at least half go away?
Right.
And but getting more than half may not be beneficial. And so it kind of comes back to why there's a mix, right?
Right. Yeah, I'm totally agree because at the end, if you have something that is like plants and trees and everything that is feeding themselves with the CO2, and then you just cut it like 100%, we will kill the entire planet because we will have no oxygen. So yes, we need to understand the right balance. Now, tell me about Mott Corporation and what do you guys do? And how are you guys able to get into so many different industries? Because I know you are a filtration company, but also flow control. But
Right.
how these approach can fit in food, space, petrochemical, and how do you manage? And let me know a little bit more about your products and the processes that you that you work with, and how you can manage to go in so many different directions because food is a totally different industry from space. So how you match that?
This is the most fun part of my job when I get to talk about this. So you'll see me
Right.
smile a lot because it's really where I get a lot of joy. You're right. We do get to play in all those markets you mentioned, and it's a lot of fun because every customer in those markets has a unique set of challenges that's quite different than the previous customer. You know, launching a filter that filters propellant fuel for a rocket to the space station is different than a challenge of carbonating beer, for example. And so, at the end, what underpins all of those at Mott, we are a filtration and flow control company, but beyond that, we're a custom engineering company that takes porous metal, ceramic, and plastic structures and deploys them into things like filters and flow control devices. The common element across all markets and all products is that we use a porous structure as a way to get something done, whether it's capturing particles, whether it's diffusing gas, whether it's carbonating your favorite beverage, whether it's an injectable medical device that helps save lives. At the end of the day, it all comes back to that porous.
Okay, and what is the difference, for example, from your type of filters from other companies? And is this difference and the characteristics that allow you to get into so many different places at the same time?
Yeah, so I believe so. So if we take just a porous metal filter, for example, it's made from sintered powders, stainless steel, hastelloy, titanium, a variety of different metals. But the way that we control those powders and turn them into a filter requires a lot of science and engineering. And we are able to create a filter that's not only highly repeatable in terms of its separation performance, but because it is a sintered and bonded piece of metal, it has the structural rigidity, the corrosion resistance, the long-term usability of a metal structure. And so if you think about comparing a porous metal filter to maybe one made of polypropylene or another type of polymer, that polymer filter will do a great job separating. It will do a great job capturing solids. But at some point, you will need to throw that filter away.
Right.
Whereas with a porous metal filter or other types of metal filters, you can perform an online cleaning over and over again for usually many years. There are some operating filters, the original filters that are 40 plus years old. They have never been needed to be replaced. They simply get cleaned, every couple months or once a year, something of that.
Wow. But how your company can be profitable when you don't need to change the filter very often? Because at the end, what I am seeing right now in the industry is the useful life of every product is decreasing because so many competitors out there that what you need is, move the product as much as you can so you can have more money out of your customer. This is a totally different approach because what you're saying is, as I understand, is don't go for the polymer filter, use this one. You don't need to change it. You just can clean it up and you can have it for 40 years. How you can make money out of this?
Yeah, it's if you're a filter element salesperson, making a sale once every 40 years doesn't feel too good, to be honest.
Exactly, right.
But if you think about the value you're bringing to your customer, that's really the important part. And so we don't just sell a filter. In my business, in the process systems business at Mott, we sell an entire filtration system. We call it a skid. It's typically arranged on a skid or a module, but it has all of the associated vessels and pumps and tanks that all need monitoring and service over time. And so we engage in those activities with our customers. And, Julio, in some applications, the filters do need to be changed more regularly. If we're talking about a highly corrosive chemical application, I could pick the best material in the world, but eventually it will corrode. And so, let me be clear, not every filter lasts for 40 years. It's great when they do.
Good clarification.
Like.
Yeah, and this is great because this is what I call the customer journey, right? It's not just to offer a customer a product, but it's to take the customer on a full journey that they don't even know that you can take them, and that makes your company a little bit different. And this is very intriguing to me. I am a material engineer, and on my thesis degree, what I did was a metallic sponge, like aluminum, like similar to a filter. And what we did was we were like having a salt, and we liquefy the salt, and then we let the salt to go into a stainless steel plate. So we create some like balls, small small balls with different diameters, and then we create a pre-shaped form. But when we have spheres, what you have is just one single contact point, right? So when we put a liquid aluminum, and with vacuum, we inject the aluminum there, and then with magnetic stirrer, we dilute the salt, and then we have the sponge. The idea was to create something similar to the bone density in order to create some materials to bone replacement. And I can see that maybe it's not the same, but you are using some of this technology, because I love the scientific point of view. I don't know if you can illustrate me a little bit more about the scientific point of view behind of your product.
Absolutely. So a highly proprietary process. I'll keep it a little bit general, but you described it quite well, actually. So, Julio, when you said a sphere bonding to a sphere means you only have one connection point. It creates a relatively weak connection. And so we use powder that is not spherical. And you could think of it like the shape of a cloud or a kernel of popcorn. It has lots of irregularities, and we control the predictability of those irregularities and the size. And then when we compact that powder together, we have multiple contact points. When we then undergo the heat treatment process, we have multiple bonding points for each of those individual parts. Now, when I'm capturing in the semiconductor space, for example, when I'm capturing particles down to 1.5 nanometer in size to almost 100% purity, we call it 9-log purity, which is 99.9979 after the decimal place pure. You can imagine the powder that I specify, the production process that I need to deploy, and then the back-end testing and validation needs to be incredibly precise to be able to give that level of assurance 24 hours a day, 7 days a week. And we have a variety of folks you can't see my screen, but right behind me in the factory who do that every day as a daily job. And they're the best in the world at it. They're quite phenomenal at making sure we give that repeatable product no matter what the industry is.
Nice. And let's move to, let's say, the approach that we can have for the aluminum industry and your company and your products. I have three topics that we can discuss. Like one is graphite electrodes. Oh, sorry for that. That I know is you are using certain like waste material, if I am not wrong, and then you are creating this type of product. So I want to know about the process. I want to know about the characteristics and how these electrodes can be useful for the aluminum industry. The other topic is green energy, and I want to talk about nuclear power, and also I want to talk about nuclear filtration. That is very intriguing to me. And the last one is going to be carbon capture and the carbonization and liquefaction of the CO2. So let's start with the graphite electrodes. So tell me about it.
Right. So graphite electrodes typically used in electric arc furnaces, which you're an aluminum expert. I'm not. My understanding is EAFs would be great for the aluminum industry as they start to convert away from rotary furnaces. But that graphite electrode, one way to make them is with a process called coking, which takes an underlying liquid hydrocarbon, puts it through a thermal process and creates kind of strings of carbon that can then be further refined and produced into an electrode. And so that coking, one way where we help that process is we filter out those impurities in that liquid hydrocarbon. And so if I start with where does that hydrocarbon come from, it is typically the last stage of leftover material from the production of transportation fuels, gases, and petrochemical processes. So if you look at a refinery and you see one of those big giant columns, those are typically a big, large reactor that takes that crude oil and cracks it into a variety of different products that end up getting converted and sold to end users. What comes out of the bottom of that is called the column bottoms, and it's still a valuable hydrocarbon, but it's filled with a lot of solid material. It could be catalyst fines, it could be waxes, it could be carbon, all sorts of stuff. What we do is purify that material so that other than it being a waste or a bunker fuel or needed to be hauled off site, it can be converted into another valuable product, one product of which is the coke product, like I mentioned, that gets formed into graphite electrode. And so in order for that coking process to work, we need to reliably separate particles, really small in size, down to micron or submicron sizes. In some cases, 24 hours a day, 7 days a week, because an oil refinery doesn't shut down for the weekends and holidays.
Right.
And our filters can't either. But by deploying our technology, a refiner or a back-end producer is able to get that higher purity to then make a valuable product that ultimately helps make other products, whether it's steel or aluminum or anything else for that.
Right. What is the difference, for example, from these type of electrodes comparing to the regular ones that we can see in the market? And from the sustainable point of view, is easier to manufacture these ones, or let's say you will use less energy, or it's just because it's a byproduct and you can take advantage of this byproduct and make something like is useful for the industry?
Yeah, my understanding of the electrodes, higher temperature, higher ability to handle that large arc that occurs in the furnace by using this particular type of electrode. And I'm not an expert on comparisons of the technology and whether or not it's easier. I would guess it's not, because it requires a couple of conversion processes.
Right.
But you are taking a waste stream that has relatively low commercial value, and you're upcycling it in a way. I think that's a term we like to talk about quite a bit now, right? You're taking something that has low value, you're performing an additional operation to it, but then you're converting it to a high value product. And so I think that's important too. Otherwise, that would just be generated waste that somebody would have to haul away or pay to dispose of.
Definitely. No, I totally agree. And I think it's a great approach, because at the end, what you want to do with the waste material is to transform that material in something that is valuable for whoever that is out there, right? Talking about green energy, and with all your experience on energy, I think green energy is something that for sure we will learn a lot from your side. Green energy, what is green energy? Why we call this green energy? And what is the approach from the nuclear point of view? And let me know about nuclear filtration, because this is very interesting for me.
Sure. I think green energy can be defined lots of different ways depending on who you ask. So I'll give you my personal definition. My personal definition is it's made from a low carbon emitting fuel source of some kind. Could be a renewable fuel source, but at a minimum, it needs to be low or zero carbon emission. And so there's a lot of components to that. It could be, wind, solar, geothermal. Nuclear would apply. There's no carbon generating process there. In the production of gases, it could be electrolysis, the making of hydrogen from water versus hydrogen from natural gas or a crude fuel source. So that, green energy can mean lots of different things. My definition, energy that is made at low or zero carbon. And you mentioned nuclear industry, so it's quite interesting. I loved my time in the nuclear industry, and now I still get to support it, just from a technology provider perspective instead of an OEM. But filtration is important in the nuclear industry. If you think about a pressurized water reactor, most common reactor type that we have here in the United States, there are 3 loops of circulating water that operate that facility. All of those loops pass through heat transfer devices of some kind, typically large heat exchangers. And one of those loops, the one that ends up getting converted to gas, also needs to pass through turbine. And so purity in those gas or liquid streams really matters. And so, we can help on the front end of making sure that water's pure. And then, as those sites reach their ultimate end state, their ultimate end of life, and some nuclear power plants are 60 plus years old now, and eventually they will be shut down just from age, not necessarily from usefulness perspective. You need to think about decommissioning of those sites. And another area where we help with nuclear filtration is the concentration of low-level radioactive waste. And so there's plenty of liquid-based waste that gets stored on site. Its radioactive concentration is quite low. And so where we can help with some proprietary processes is to concentrate that nuclear waste so that the volume is smaller. And ultimately, as a society, we're storing a smaller waste volume rather than a larger one. And so I can't really get too much into the details of how that's done, but that's in essence the couple of missions that we solve in nuclear filtration. Just a personal perspective on nuclear power, I think it's a really great base load green energy source for the United States, for anywhere in the world, quite frankly, but especially us here domestically, and something that I hope we for many, many.
Right. And why do you think that people is that like going away from the nuclear power and seeing right now all these green energies, but not putting the nuclear power into the green energies for the future? Because, for example, if you go and see Germany, they shoot it down, all this nuclear power that they used to have there, and now they are depending on Russia or other countries, and it's putting the economy in risk. Why do you think the people is moving away from this type of energy that is almost unlimited? We really know how to work with. For me, it's not dangerous. We had some issues in the past, and I understand that some of those issues was because of the nature, right? Tsunamis and other things. But why do you think people is not focusing on this type of energy that is completely green, is almost unlimited source of energy, and we already know how to treat this type of energy with the technology that we have?
Yeah, it's a shame, and I wish that wasn't the case, of course. But from my perspective, I see a couple areas why society might away from nuclear power. So first, I think technical understanding. While the folks who operate nuclear power plants, design and service nuclear power plants, they are absolute experts and understand the technology incredibly well. I think the broader public, it still feels like a little too much science, maybe. And so I think it's easy to be understood. It's easy to be misassociated. And we could educate more on exactly how safe it is. It is incredibly safe. But I think there's always this misunderstanding factor that weighs into things. Second area is cost. I don't think nuclear power will ever be the cheapest per kilowatt hour or megawatt, however you want to frame that. But again, it's about a mix. It doesn't need to be. What nuclear power does give you is incredibly high uptime, resilience to transient events, weather, and things like that, and long periods in between needing to be refueled, because to your point, Julio, the source of nuclear fuel is almost limitless, and it requires a really small amount of raw material in order to make the fuel source. And so, but again, coming back to cost, it simply isn't as cheap as natural gas, for example. And so that plays a little bit into it. Again, I wish it wasn't the case. I think it's a great baseload power. I'm a little sad with Germany's decisions. I don't live there. I don't know what public policy is like, but I have to wonder if that strategy is being thought about again in light of the recent geopolitical events, like you mentioned. But again, it's a technology that I think the world needs to continue to embrace and include as part of a balanced energy portfolio.
How many nuclear power plants do we have here? Do you have an idea in the US?
I think there's roughly 80 to 90 commercial operating units, somewhere in that range. And they're, kind of three main technology types, but they all functionally do the same thing. They all produce heat from a nuclear fission reaction to, one way or another, convert water to steam and use that energy to to generate electricity.
And when we talk about nuclear filtration, so you are recovering this water that they are using, and how is the percentage of water that you can recover out of this process?
So in the remediation side, we can recover roughly 70 to 80% of the water. It depends a lot on what's in the water. And you can imagine that that's sometimes difficult to get precise about given
Right.
where the water comes from. But we can recover roughly 70 to 80% of that water in a typical application.
And is possible to consume this water, or is just for to reuse it in the same process?
General industrial use would be best.
Right.
Scientifically, like I said, anything's possible with effort and time.
Right.
But when you think of ease of business use, general industrial use.
Right. Now, carbon capture and decarbonization and liquefaction, what that means and how this is helping to approach on the sustainable point of view to the society.
Yeah, so carbon capture, utilization, and storage, sometimes called CCUS, really fast growing initiative in kind of traditional industrial production, and you can have carbon capture all over the place. It can be at a oil refinery, a chemical plant, a petrochemical plant, a power plant, but it all boils down to the same underlying mission: how to prevent carbon from escaping into the environment and capture it and repurpose it in some way. And that comes back to that statistic I talked about a little bit earlier.
Right.
A couple of areas where we help with carbon capture is in the production of hydrogen. There is a method by which you can capture CO2 or methane as a byproduct or escape mechanism, and then scrub and liquefy that CO2. And so where we help in that process is the purification of that CO2. And so if you imagine, just let's go back to engineering principles, gases aren't very dense, and therefore, unless they're at incredibly high pressure, they're really inefficient to store. And so as you're capturing all this CO2, you need to find a storage mechanism for it. And the easiest way to store it is to liquefy it, because you're able to take advantage of that density difference and it becomes a bit more efficient. And so where we help is making sure that there is no moisture content in that CO2 prior to liquefaction. If you imagine you have a CO2 gas stream with some content of leftover moisture and you go through liquefaction, well, your steam becomes water, becomes ice quite quickly. And that leads to a whole host of problems that nobody really wants to deal with, breaking of pipe clogs and things like that. Yeah. And so what we do is make sure that that CO2 stream in that carbon capture process is 100% void of water or moisture, and then therefore can be easily liquefied for the purposes of storage, injection into a pipeline, other commercial reuse of that.
Right. And as I can understand, you can use this type of approach in so many different industries. Every industry that is creating CO2 emissions, you can just put it there and capture and liquefy it.
Absolutely.
You said something about hydrogen. What do you think about hydrogen as a potential energy source on so many different industries? Because people, I think, is going more and more on this direction, that hydrogen is the new top of the energy, right? To me, I think it's a good option. I think it's quite expensive to develop and create hydrogen, and it's quite complicated. And I don't know if hydrogen will have enough power to whatever it is, for example, on the aluminum industry, to melt aluminum down. So I think we will need a mixture between natural gas and hydrogen. And for me, I don't know if that makes sense from the financial point of view, but let's say that this is very a specific topic, but from the point of view of the general point of view of the hydrogen creation and hydrogen useful on these type of approaches, what are your perspective?
I think it's a fantastic energy source. Like we've talked about a few times in this conversation, I think energy is all about balance and mix. And if you are 100% one way, you're going to leave yourself open to vulnerabilities, right?
Right.
And so I think hydrogen's a fantastic fuel source. I think it's incredibly important for us to continue to develop hydrogen-related technologies. From other businesses at Mott, I see tons of uses for hydrogen today. Mobility, conversion into electrical storage and eventual reuse. Eventually maybe even into passenger vehicles or large hauling trucks and things of that nature. But your point is real. To make hydrogen with a sustainable method today, electrolysis, it's expensive. It's more expensive than traditional methane reforming, and so you have to acknowledge that difference. But if we don't continue to invest in those technologies, we won't find those technological breakthroughs. We won't
Right.
find those opportunities to be more efficient. And eventually, if we continue to keep growing that market, I am fully confident that we'll find a new way to do things that is more efficient and brings cost down to parity or maybe even better. A good analogy to think of is big screen TVs. If we think, 15, 20 years ago, to have a big screen TV in your home, you were quite lucky
Right.
because they were very expensive. Today, we're quite fortunate that we invested in that technology and it's now accessible to everybody, right?
Yeah.
And so I view technology development in hydrogen the same exact way. We must continue to invest. We will find breakthroughs as a society, and ultimately that will help shift our mix to something a bit more sustainable as well.
Right, and I think as what I can see, like having some conclusions here is everything is matter of time and effort, right? Because at the end you need to go through all these, let's say, challenges that you will see in every new technology approach. But in some point you will break down all these, let's say, troubleshooting that you will see, and then you will improve the technology. This is going to be cheaper in some point, but also I think it's very important what you are, like what you've been saying through the whole episode, that is we need to understand that it's a mixture and it's a balance of things. It's not just going in just one direction and focusing in just one let's say a specific approach. Is to have an open mind and understand that what we need to do is to mix it up everything in some way that everything is balanced and can give us let's say the final goal and the approach that we want. Now, to going into the end of the episode, what is the future that we can see in, let's say, the short and the medium and long term from Mott and from the company that will give us a different approach for the future? What is the future?
Yeah, so future for me is keeping that mix, but building out automation, control, repeatability to technologies. And so as it relates to filtration, filtration plays a part in all of those industries that we talked about, no matter what your energy source is, quite frankly. My job is to make sure that I can arm my customers with filters that are autonomous, easy to operate, supported by engineers all around the world, and don't require as much hands-on presence as they do today. And I think that kind of automation and monitoring piece plays across technology as we look to develop as well.
Great. Patrick, I want to say thank you very much for your time. I really appreciate all this input that you are giving to us. I think it's amazing to understand that it's not just aluminum that is the industry that is pushing hard on the sustainability point of view, but it's also so many different companies out there and so many different industries and approaches that we are seeing that are going in the same direction. At the end, I think if we can understand that a lot of people have some different ideas are pulling into the same direction, is because something is, let's say, changing in the human brain right now. So thank you so much for your time. I really appreciate it, and hopefully you enjoyed this as much as I enjoyed it. Was amazing for me to understand all these different type of processes and approaches. And for Mott, I just can say that I really are impressed about what you're doing, guys. The point of view of filtration and how this small, let's say, approach is changing the world of the industry and helping so many different industries is crazy for me. But I really appreciate your time, your input, and I just can say thank you so much.
Thanks, Julio. It was a great conversation. I think it's really important that we always stay at the boundaries of where we're comfortable and uncomfortable, no matter the industry, because that's ultimately what's going to drive change and innovation. So awesome to talk to you today. Really thankful for you having me on the show, and I really appreciate it.
Oh, no, my pleasure. And hopefully this is the first time, but in the future, I want to have more feedback from your side. And if you have a crazy idea that you can share with us in the future, just let us know. we will be more than happy to have you again in this platform.
Absolutely.
Okay, Patrick, thank you so much. Really
Take care.
appreciate it. Bye-bye.
Bye.
Dirty Scrap Podcast.